The surface of this planet is restless. Rock melts, reforms, and is folded back into itself. Oceans recycle their flaws. Atmospheres change composition. Ice advances and retreats. Given enough time, Earth does not merely erase footprints, it erases entire worlds. Human civilization often feels unprecedented. Cities glow at night. Machines alter climate. Signals spill into space. It is tempting to believe this moment stands alone, the first time intelligence has reshaped a planet through industry and technology. But deep time invites a quieter question. What if intelligence is not a single event? What if it is a recurring phase, appearing when conditions allow, vanishing when conditions change, leaving behind only the faintest planetary echoes? Geology shows that Earth remembers violence better than achievement. A single asteroid impact leaves a thin chemical line that survives for tens of millions of years. Vast mountain ranges, once taller than anything alive today, can disappear entirely. Oceans can vanish and return. Atmospheres can be rebuilt from scratch. Against this backdrop, the lifespan of a technological civilization is vanishingly small. Even tens of thousands of years register as a blink within planetary history. Buildings collapse. Metals corrode. Plastics fragment. Knowledge fades. What remains is not architecture or machines, but chemistry, isotopes, and altered cycles written quietly into stone. Modern science has begun to ask whether those subtle signatures could exist from far earlier chapters. Not as proof, not as discovery, but as a boundary question. A thought experiment grounded in what Earth preserves and what it destroys. This idea does not claim that ancient civilizations existed. It asks something more restrained and more unsettling. If one had existed, would anything recognizable remain? The deeper this question goes, the more it becomes less about lost cities and more about the nature of planets, memory, and intelligence itself. Earth may not record history as a story, but as layers. And within those layers, absence can sometimes be as meaningful as presence. This is not a search for certainty. It is an exploration of possibility, a journey into deep time, where speculation meets geology, and where the silence of stone invites one of the oldest questions intelligence can ask. Has this world tried before? To understand how a civilization might vanish almost completely, it helps to look at how Earth treats everything placed upon its surface. Continents are not stable platforms, but slow-moving rafts of crust floating on a convecting mantle. Over tens of millions of years, coastlines migrate, mountain belts rise and collapse, and entire regions are dragged downward and recycled into molten rock. Anything built on the surface is temporary by default. Erosion works patiently but relentlessly. Wind abrades stone grain by grain. Water dissolves minerals, transports sediments, and buries what once stood tall beneath layers of silt. Even the hardest materials fracture under repeated thermal expansion and chemical attack. Iron rusts. Concrete cracks. Glass devitrifies. Given enough time, cities dissolve into dust indistinguishable from natural sediment. Oceans erase even faster. The seafloor is among the youngest terrain on the planet. No oceanic crust older than about 200 million years survives today. Everything beneath the waves is eventually pulled into subduction zones and destroyed. Any coastal or underwater civilization would leave almost nothing once plate tectonics completes a single cycle. Biology accelerates the erasure. Roots pry apart stone. Microorganisms digest metals. Life repurposes structures as habitats and nutrients. What is not buried is broken down. What is buried is altered by pressure, heat, and chemistry until it no longer resembles its origin. Against this background, the survival of fossils themselves seems almost miraculous. Fossilization requires precise conditions, rapid burial, low oxygen, and chemical stability. Even then, it captures only a fraction of life. Soft tissues vanish. Entire ecosystems leave no trace. The fossil record is not a catalogue of life, but a sparse sampling shaped by chance. Technology fares no better. Machines are complex but fragile. Their components disperse. Their energy sources vanish. Their structures collapse. After a few million years, only materials altered at the atomic level have any hope of remaining recognizable. This is where speculation begins to intersect with known science. Earth preserves global changes far more reliably than local ones. It remembers shifts in atmosphere, chemistry, and energy balance better than it remembers objects. When volcanic eruptions occur on massive scales, they leave fingerprints in isotope ratios and sediment layers across the planet. When asteroids strike, they deposit thin layers enriched with rare elements that can still be measured tens of millions of years later. When climate changes abruptly, ice cores and ocean sediments quietly record the transition. An industrial civilization, even a brief one, would not simply build structures. It would alter cycles. Energy use would change atmospheric composition. Material production would redistribute elements. Waste would spread globally. These changes would not announce themselves as artifacts, but as anomalies. This idea sits at the heart of a speculative framework sometimes referred to as the Silurian hypothesis. It does not propose that ancient civilizations existed. It asks whether the geological record is capable, in principle, of preserving evidence of one, and whether modern science would recognize it if it did. The answer is neither comforting nor dismissive. It is uncertain. Consider carbon. Carbon moves through Earth in slow cycles, linking atmosphere, oceans, rocks, and living systems. Burning large quantities of buried carbon, such as coal or oil, shifts the balance. The isotopic signature of this carbon is distinct, lighter than that produced by most natural processes. Today, this shift is measurable everywhere, from tree rings to polar ice. In deep time, similar carbon isotope excursions appear. Some coincide with mass extinctions and rapid warming events. Mainstream explanations involve volcanism, methane release, or ocean chemistry changes. These explanations are plausible and often well supported. Yet the patterns themselves demonstrate something important. Earth records sudden global carbon disturbances with remarkable clarity. If an ancient civilization released carbon on a large scale, the signature would resemble these events. It would not label itself. It would blend into categories already used to describe natural catastrophes. The same applies to other elements. Nitrogen, sulfur, and oxygen cycles can all be perturbed rapidly under certain conditions. Industrial activity modifies these cycles today. In the distant past, similar disruptions are visible, though their causes remain debated. Speculation enters quietly here, not as a claim, but as a mirror. The geological record shows that Earth has experienced abrupt, planet-wide chemical changes multiple times. Some are understood. Others remain only partially explained. The question is not whether these were caused by intelligence, but whether intelligence, if present, would be distinguishable from catastrophe. This uncertainty opens a narrow but profound space. It suggests that civilization may be geologically subtle, not dramatic. That intelligence may pass through Earth's systems like a brief perturbation, rather than a permanent scar? If so, then the absence of evidence is not evidence of absence. It is simply what deep time does best. Mass extinctions offer another lens through which this question becomes interesting without becoming ungrounded. Earth has experienced several moments when life collapsed on a planetary scale. Species disappeared rapidly. Ecosystems unraveled. Recovery took millions of years. These events reset the biological surface of the planet so thoroughly that what came before is often known only through fragments. From a geological perspective, mass extinctions are among the most effective erasers imaginable. They remove dominant life forms, disrupt food webs, and radically alter environmental conditions. Forests vanish. Oceans change chemistry. Soil structures collapse. Any surface-based civilization would not merely decline during such an event, it would be dismantled at every level. The end Permian extinction, sometimes called the Great Dying, stands as the most severe example. Nearly all marine species disappeared. Vast regions of land became hostile to complex life. Temperature, acidity, and oxygen levels shifted dramatically. The cause is generally linked to massive volcanism in what is now Siberia, releasing enormous quantities of carbon dioxide and other gases. What matters here is not the cause itself, but the outcome. The planet entered a state where complexity was stripped away. Whatever technological or cultural structures might have existed would have been erased alongside biological ones. The rock record would remember the chemical disruption, not the societies lost within it. This pattern repeats. The end Triassic extinction. The end Cretaceous extinction. Each time, life is reset. Each time, recovery builds something new on top of what remains. From a distance of hundreds of millions of years, these events appear as boundaries, not narratives. If intelligence had arisen before humans, even briefly, it would have been subject to the same planetary forces. It would not receive special treatment. It would not be preserved out of significance. It would be processed like everything else. This reframes the idea of ancient civilization away from mystery and toward humility. The planet does not care whether a structure is natural or designed. It cares only about chemistry, pressure, and time. Another constraint emerges when considering energy. Civilizations are defined not by tools, but by energy flow. The more complex a society becomes, the more energy it must move through itself. Fire, agriculture, industry, computation, all scale with energy consumption. Energy use leaves signatures. It alters landscapes. It modifies atmospheric composition. It changes erosion patterns. These effects scale globally once a civilization becomes sufficiently advanced. Modern industry has already produced such signatures. Atmospheric carbon dioxide has risen sharply. Synthetic compounds appear in sediments. Reactive nitrogen circulates at unprecedented rates. These changes will remain visible long after cities disappear. The speculative question is whether similar signatures could exist in the past, hidden within layers already attributed to natural processes. Not hidden deliberately, but hidden by familiarity. Some ancient climate events display features that resemble rapid energy release. Sudden warming, ocean acidification, disruption of carbon storage. These events are usually linked to volcanism or methane hydrate release, and in most cases those explanations are compelling. Yet the similarity itself is revealing. Industrial activity and geological catastrophe can converge in outcome even when origins differ. To the planet, a surge of greenhouse gases is simply a surge of greenhouse gases. This convergence limits what evidence could ever prove. Even if intelligence had once altered the planet, the signal would be ambiguous by nature. It would be interpretable only through context and probability, never certainty. Materials offer another constraint. Many modern substances feel permanent, yet most degrade surprisingly quickly. Plastics fragment. Polymers break down under heat and radiation. Metals oxidize. All of this accelerates under burial and pressure. Only trace remnants might survive, scattered at microscopic scales. Over time, these remnants would mix with sediments and minerals, becoming statistical anomalies rather than objects. From a future perspective, human civilization may not be remembered as cities and machines, but as a thin layer where certain compounds briefly spike before fading again. This perspective makes the question of first civilization feel less like a hunt for ruins and more like a meditation on impermanence. Intelligence does not announce itself in stone tablets that endure forever. It whispers briefly into planetary cycles and then falls silent. Seen this way, Earth's past becomes less empty and more unknowable. Not because something must be missing, but because the planet itself is indifferent to memory. The mystery, then, is not whether ancient civilizations existed. The mystery is whether Earth would ever allow one to be known. Atmosphere provides one of the most reliable archives Earth possesses. Unlike buildings or landscapes, air mixes globally. Changes made in one region spread everywhere. Over time, these changes become locked into ice, sediments, and chemical balances that persist long after the original cause disappears. Air trapped in polar ice records composition with remarkable precision. Ratios of gases reveal temperature, biological activity, and chemical disturbances stretching back hundreds of thousands of years. Beyond ice, ancient air leaves traces dissolved in ocean sediments and bound within certain minerals. Together, these records form a long, continuous memory of planetary breathing. Modern industrial activity has altered this memory dramatically. Carbon dioxide levels rise rapidly. Methane follows. Nitrous oxides appear in unusual ratios. These shifts are sharp enough that future scientists would identify them instantly as anomalies rather than gradual trends. When looking deeper into Earth's past, similar anomalies appear. There are periods when greenhouse gases spike abruptly. Warming occurs faster than expected. Ocean chemistry shifts in step. Life responds with stress, migration, and extinction. These events are almost always attributed to natural causes, and often with good reason. Volcanic provinces capable of covering continents in lava do exist. Methane stored beneath oceans can be released catastrophically. Earth has internal mechanisms capable of dramatic change. What matters here is not replacing those explanations, but noticing something quieter. Planetary systems do not distinguish intent. They record outcome. A rapid atmospheric shift looks the same whether it is caused by magma or machinery. This places a hard limit on detectability. Even a civilization capable of altering climate would leave a signal that blends into the category of catastrophe. Without accompanying artifacts, interpretation becomes an exercise in probability rather than proof. This ambiguity extends to oxygen itself. Earth's atmosphere has not always supported complex life. For most of its history, oxygen was rare. When it finally rose during the Great Oxygenation Event, it triggered a mass extinction of anaerobic life while enabling new biological complexity. That event reshaped the planet more profoundly than any known civilization ever has. It changed mineral formation, ocean chemistry, and energy flow across the biosphere. Yet it was driven by microorganisms, not intelligence. The lesson is subtle. Planetary scale change does not require intention. It requires only scale and time. Intelligence is not the only force capable of reshaping worlds. This complicates the idea of a technological past. If intelligence once arose, it would not stand out as unique in the geological record. It would compete for interpretive space with volcanoes, microbes, and orbital mechanics. Some researchers have asked whether synthetic compounds could survive long enough to be recognizable. Certain molecules are exceptionally stable. Fluorinated compounds, for example, resist breakdown under extreme conditions. In theory, traces could persist far longer than organic materials. Yet even here, survival does not guarantee clarity. Over millions of years, molecules are diluted, altered, and incorporated into new chemical contexts. What began as artificial becomes statistically rare, then chemically ordinary. What remains are patterns, not objects. Ratios that feel slightly off. Distributions that require explanation. Signals that prompt new models rather than conclusions. This is where awe quietly enters. Earth is not a static archive waiting to be read. It is an active system constantly rewriting itself. To imagine intelligence emerging within it is to imagine a brief phase change rather than a permanent state. Civilization, in this view, becomes an experiment the planet runs occasionally when conditions align. It flares briefly, reshapes flows of energy and matter, and then dissolves back into geology. Nothing about this requires certainty. Nothing demands belief. It simply acknowledges how small, even powerful intelligence appears when placed against billions of years of planetary motion. The question of first civilization then loses its sharp edge. What matters is not priority, but recurrence. Not who came first, but how often conditions allow complexity to rise before being folded back into stone. In that sense, the silence of the deep past is not empty. It is simply vast. Another way to approach the question is to examine how unevenly time treats different kinds of evidence. Human history feels dense because it sits close to the present. Written records, ruins, tools, and traditions overlap and reinforce one another. Step back a few thousand years and that density thins. Step back a few million and it nearly disappears. Geological time compresses narratives into signals. A 1,000-year civilization and a 10,000-year civilization may leave nearly identical traces once reduced to chemistry. Duration matters far less than intensity. A brief but energetic phase can outweigh a long but quiet one in the planetary record. This leads to an unsettling possibility. A civilization does not need to last long to matter geologically. It only needs to act at scale. A few centuries of intense energy use could outweigh tens of thousands of years of low-impact existence. From this perspective, humanity's current phase is already extreme. Energy flows through civilization at rates unprecedented in biological history. Matter is extracted, refined, transported, and dispersed globally. Even if this phase ended abruptly, its imprint would persist. If something similar occurred in the distant past, the record would not preserve its story, only its footprint. And even that footprint would be filtered through interpretation. Consider rare elements. Modern technology concentrates metals that are normally scattered thinly through Earth's crust. Mining and refining move them into new configurations. Over time, erosion and burial redistribute these materials again, but not perfectly. Subtle enrichments remain. In the distant future, a geologist might find layers where certain metals briefly spike before returning to background levels. The immediate explanation would likely involve unusual geological processes. Industrial concentration would not be the first thought. This pattern repeats across systems. Agriculture reshapes soils. Urbanization alters sediment flow. Energy production modifies isotope ratios. All of these effects can be large, yet none point unambiguously to intention. Even fossil fuels themselves complicate the story. Coal and oil are products of ancient biological abundance preserved under rare conditions. Their very existence is a geological accident. A civilization that never relied on such fuels might leave even fewer traces. This opens another speculative door. Intelligence does not require a specific technological path. An ancient civilization might have used energy sources that leave weaker geological signatures than fossil fuels. Geothermal gradients, tidal forces, or biological energy systems could support complexity without dramatic atmospheric change. If so, detectability becomes even more limited. The absence of strong anomalies would not argue against existence, only against recognizability. At this point, speculation remains bounded by physics rather than imagination. Energy must come from somewhere. Waste must go somewhere. Entropy cannot be avoided, but the form those processes take can vary widely. Earth's history shows repeated experimentation, oxygenation, multicellularity, consciousness. Each emerged once conditions aligned, not because they were inevitable, but because they were possible. It is not unreasonable to wonder whether intelligence could follow the same pattern. Not as a single ascent, but as something that arises, collapses, and reappears under favorable circumstances. This framing shifts the emotional weight of the idea. It is no longer about hidden empires or forgotten machines. It is about humility in the face of deep time. If intelligence has appeared before, it did so without ceremony. It did not carve its name into the planet. It passed through Earth's systems quietly enough that its memory could be mistaken for background noise. And if that is true, then the most remarkable thing about human civilization may not be that it is first, but that it is visible at all. The planet does not preserve stories. It preserves consequences. The idea that intelligence might recur rather than arrive once becomes less strange when viewed alongside Earth's broader patterns. Life itself did not appear immediately when the planet formed. It waited. Conditions cooled. Chemistry stabilized. Energy gradients emerged. Only then did complexity take hold. Even after life began, it remained simple for most of Earth's history. Multicellular organisms appeared late. Nervous systems appeared later still. Conscious awareness, as far as can be inferred, arrived only within the final fraction of planetary time. Each step required specific conditions, and each step was reversible. This suggests that intelligence is not a guaranteed outcome, but a contingent one. It depends on stable climates, available energy, chemical diversity, and long periods without total disruption. When those conditions fail, intelligence does not merely pause, it disappears. Earth has experienced long intervals where such conditions were absent. Extended ice ages, extreme greenhouse states, oceans depleted of oxygen, impacts that altered climate globally. During these phases, even complex life struggled to survive, let alone organize technologically. Yet between these extremes lie windows of relative calm, tens of millions of years where climate stabilized, ecosystems diversified, energy flowed predictably. These windows are when complexity flourishes. Speculation arises naturally here. If intelligence can emerge once under such conditions, it may be capable of emerging again under similar circumstances. Not because history repeats itself, but because physics allows similar outcomes when constraints align. The difficulty lies in recognizing such outcomes after the fact. Intelligence does not fossilize easily. Ideas leave no bones. Social structures leave no shells. Even technology leaves only indirect signatures once stripped of context. This may explain why the fossil record feels discontinuous. Not because intelligence intervened, but because complexity itself appears in bursts separated by long plateaus. Evolution accelerates under pressure, then stabilizes, then resets. Civilization, if it arises, would sit atop these bursts rather than define them. It would be layered onto biology, not separate from it. From this view, intelligence is less a pinnacle and more a transient phase. A way matter briefly organizes itself to move energy more efficiently before collapsing back into simpler forms. That collapse need not be dramatic. It could occur gradually. Resources deplete. Climate shifts. Populations fragment. Knowledge fades. Within a few thousand years, technology regresses. Within a few million, geology finishes the job. Nothing in this process would require catastrophe or malice. It would be the same slow forgetting that claims everything else. This framing also softens the emotional charge of the question. The idea of not being first does not diminish human significance. It situates it. Human civilization becomes one expression of a deeper planetary tendency. A moment when matter learned to reflect on itself under favorable conditions. What matters, then, is not whether this moment is unique, but whether it is brief or sustained. Earth's past suggests that stability is rare and fragile. Long-term persistence requires restraint, adaptation, and alignment with planetary systems, rather than dominance over them. Seen through deep time, the question of first civilization becomes inseparable from the question of last. Not who came before, but whether anything ever learned to stay. When viewed from a sufficient distance, civilization appears less like an achievement and more like a phase transition. Matter arranges itself into systems capable of abstract thought, symbolic communication, and deliberate energy manipulation. For a brief span, feedback loops accelerate. Knowledge compounds. Tools reshape environments faster than biology alone ever could. Then, just as gradually or suddenly, the conditions that allowed that acceleration change, and the system collapses back towards simpler states. Earth's history contains many such phase transitions. Oceans oxygenate. Ice ages begin and end. Continents assemble and break apart. Each transition opens possibilities while closing others. Intelligence, if it emerges, must exist inside these constraints rather than above them. This makes longevity the rarest property of all. It is not enough to become complex. Complexity must be sustained across shifting climates, geological upheaval, and biological competition. Most systems fail this test. Even dominant species disappear. Entire lineages vanish without leaving descendants. Expecting civilization to be exempt from this pattern may be an expression of proximity rather than reason. One of the most striking features of Earth's record is how quickly dominance changes. For tens of millions of years, a particular form of life may shape ecosystems. Then, within a geological instant, it is gone. The replacement is not an improvement, merely a survivor adapted to new constraints. Intelligence would follow the same rule. It would not be protected by its insight, only constrained by its environment. This perspective reframes the absence of ancient technological evidence as expected, rather than mysterious. A civilization that rose during a stable window would eventually face environmental drift. Sea levels would change. Carbon cycles would shift. Energy sources would become less accessible. What began as adaptation could become overreach. What began as control could become instability. None of this requires a single dramatic failure. Attrition alone is sufficient. As technology regresses, global signatures fade, atmospheric perturbations relax, chemical imbalances are absorbed by oceans and rock, industrial byproducts disperse until they are statistically indistinguishable from background variation. Over millions of years, even dramatic changes smooth into trends. This slow smoothing is one of Earth's defining characteristics. The planet behaves less like an archive and more like a blender. It does not erase selectively. It erases everything given time. Only the most violent or global events resist this process, and even they are eventually reduced to thin lines and ratios. From this angle, intelligence is not written boldly into the rock record because nothing is. The expectation that it should be visible may stem from misunderstanding scale rather than absence. A city feels immense from the ground. From orbit, it is a pattern of lights. From geological time, it is nothing at all. The more deeply this is considered, the less meaningful the question of first becomes. Priority dissolves under time. What remains is recurrence. How often does Earth enter states that allow intelligence to arise? How long do those states persist? How resilient is complexity when conditions drift? These are questions science can approach without abandoning rigor. They do not require belief in hidden artifacts or lost empires. They require only acceptance that Earth's memory is coarse and that most events are filtered into anonymity. Speculation, in this context, is not an escape from science, but an extension of it. It acknowledges known limits. It respects what geology preserves and what it destroys. It asks not what must have happened, but what could have happened without contradiction. The awe does not come from imagining grand predecessors. It comes from recognizing how narrow the window for any civilization truly is, how easily the planet can move from abundance to hostility, how briefly intelligence flickers against a background of stone and time. In that light, the silence of the deep past is no longer empty. It is simply unresolved. The longer this idea is held in view, the more it shifts away from archaeology and toward planetary behavior. Earth does not operate like a museum preserving achievements. It operates like a system constantly redistributing energy, matter, and structure. Anything that emerges within it must either align with that motion or be absorbed by it. Intelligence is not exempt. It is simply another process moving energy through organized forms, briefly accelerating flows before entropy resumes its work. What feels unsettling is not the suggestion that intelligence could have appeared before, but how easily such an appearance could dissolve without trace. The planet has mechanisms specifically suited to erasing surface history. Plate tectonics consumes crust. Weather grinds structures into sediment. Chemical cycles recycle elements endlessly. Even information, once encoded in physical form, decays as its substrates break apart. From this perspective, forgetting is not a failure of the record. It is the default state. This casts modern civilization in a new light. Its apparent permanence is an illusion created by recency. Satellites, databases, and global infrastructure feel enduring only because they have not yet faced geological time. Against millions of years, even nuclear waste becomes diluted, buried, and transformed. Against hundreds of millions, even continents rearrange beyond recognition. Expecting recognizable evidence of deep time intelligence may be equivalent to expecting ripples to remain visible long after the stone has sunk. What science can detect are not stories, but disruptions, deviations from baseline behavior, moments when Earth's systems behave differently than expected. These disruptions do not carry labels. They require interpretation. Most are attributed to natural causes because natural causes are abundant and sufficient in most cases. Yet attribution does not equal certainty. It reflects the best explanation available given incomplete information. This is where the speculative edge remains narrow but real, not in claiming alternative explanations, but in admitting that explanations operate within constraints of evidence and expectation. If intelligence were rare, brief, and erased by subsequent planetary resets, its signatures would be subtle by necessity. They would overlap with known phenomena rather than stand apart from them. Seen this way, the absence of consensus is not a failure of imagination or courage. It is a reflection of how deeply time buries complexity. Earth's past is not hiding secrets in the sense of concealment. It is indifferent to whether secrets remain visible at all. There is also a psychological dimension to this question. The desire to be first is tied to identity. It reinforces narratives of progress and uniqueness. Letting go of that desire can feel destabilizing. Yet deep time offers something more expansive. It places intelligence within a continuum rather than at a pinnacle. It becomes part of Earth's experimentation rather than its conclusion. In that continuum, humanity's moment remains extraordinary, regardless of whether it is unique. The ability to ask these questions at all, to reconstruct planetary history from isotopes and ice, to wonder about intelligence beyond the present, is itself remarkable. It does not require exclusivity to retain meaning. As speculation fades toward philosophy, the question transforms again. If intelligence can arise, vanish, and arise again, then the future matters more than the past. Longevity becomes the true challenge. Not discovery, not dominance, but persistence within planetary limits. Earth has shown that it can host complexity. It has also shown that it will not protect it. Any civilization that hopes to endure must align itself with cycles far larger than culture or technology. It must learn to operate as a phase that stabilizes rather than destabilizes the systems that support it. In this sense, the question of first civilization is less a mystery to be solved and more a lens through which to view responsibility. Whether or not intelligence came before, the planet behaves as though it will erase whatever comes next unless something fundamentally changes. The awe lies here, not in hidden histories, but in the fragile improbability of sustained intelligence on a restless world, and in the quiet realization that Earth has been here long before thought and will remain long after, indifferent to whether it ever learns to remember us. When framed this way, the question opens outward rather than backward. It stops being about what might be buried beneath continents and becomes about what kind of relationship intelligence has with time itself. Civilization feels permanent only when viewed from inside its own lifespan. From the outside, it resembles a brief alignment of conditions, chemistry, and organization that can unravel as easily as it forms. Deep time suggests that complexity is tolerated, not guaranteed. Earth allows it under certain constraints, then withdraws that permission without warning or intent. Ice advances. Seas rise. Volcanic provinces ignite. Orbital cycles shift sunlight across hemispheres. None of these processes are hostile in themselves. They are simply indifferent. If intelligence emerged before, it would have faced the same indifference. It would have navigated climates it did not control, tectonics it could not stop, and biological systems that evolved regardless of intention. No amount of insight exempts a civilization from thermodynamics or orbital mechanics. This indifference may be the most important lesson hidden in the speculation. It suggests that intelligence is not a destiny written into the planet, but a negotiation with it, a temporary agreement between stability and ambition. What survives of that agreement is never meaning or purpose. It is imbalance. slight shifts in ratios, thin boundaries in rock, brief anomalies in chemical cycles. The quieter the civilization, the harder it is to notice. The louder it becomes, the more it risks triggering the very resets that erase it. From this perspective, the idea of recurring intelligence becomes almost natural. Not miraculous, not conspiratorial. Simply the outcome of similar constraints producing similar results at different times. When conditions permit complexity, it arises. When they do not, it collapses. This does not diminish the present moment. It deepens it. It places humanity within a lineage of possibility, rather than at the center of a story. The planet is not waiting for intelligence. Intelligence happens when the planet allows it. The geological record, then, is not silent because nothing happened. It is quiet because Earth speaks in slow averages rather than narratives. It remembers temperatures better than thoughts, pressures better than plans, ratios better than reasons. Science, constrained by this record, can never fully answer whether intelligence arose before. It can only bound the question. It can say what would survive, what would vanish, and what would become indistinguishable from natural background. That boundary is where awe lives. Not in certainty, but in scale. Not in revelation, but in humility. The deeper one looks into Earth's past, the more fragile the present appears. The more improbable it feels that complexity has lasted this long without being reset. And the more pressing the question of whether it can persist without triggering its own erasure. If intelligence has visited this planet before, its greatest legacy may not be traces left behind, but warnings never recorded. Lessons absorbed by no one. Patterns repeated, because memory itself was temporary. And if it has not, then the responsibility becomes even heavier. For the first time, Earth would be hosting a civilization capable of understanding the forces that erase it, while still being subject to them. Either way, the planet remains the same. Old, patient, restless. It does not promise remembrance. It only offers time. At the largest scale, birth behaves less like a stage for stories and more like a set of conditions that periodically allow complexity to assemble, only to disassemble it again when those conditions drift. This behavior does not imply intention or design. It emerges naturally from thermodynamics, orbital mechanics, and geochemical cycles operating over immense spans of time. Within that framework, intelligence is neither special nor irrelevant. It is simply one of the more elaborate ways matter has learned to move energy before returning to simpler arrangements. What gives this idea weight is not speculation about lost structures or forgotten technologies, but the repeated observation that stability is fleeting. Earth's climate has oscillated between extremes many times. Long periods of warmth have been followed by deep freezes. Sea levels have risen hundreds of meters and fallen again. Continents have collided, fractured, and reassembled. Each transition reshaped ecosystems completely. Life survived by adapting or retreating, not by preserving continuity. Intelligence, if it arose during one of these stable intervals, would have been bound to the same impermanence. From this perspective, civilization is not erased by a single dramatic failure. It is eroded by mismatch. A society evolves under one set of environmental assumptions, then slowly finds those assumptions invalid. Food systems fail first. Energy systems strain next. Social complexity fragments under pressure. Knowledge becomes harder to transmit as institutions weaken. By the time collapse is complete, little remains that could ever be recognized as intentional design. Geology finishes what social breakdown begins. Structures collapse and are buried. Metals corrode and disperse. Manufactured materials fragment and are incorporated into sediments. Chemical signatures are diluted through oceans and rock until they blend into background noise. Over millions of years, even the most dramatic industrial disturbances become gentle curves in data rather than sharp events. This smoothing effect makes the search for ancient intelligence uniquely difficult. Any signal that survives must compete with natural processes capable of producing similar outcomes. Carbon isotope excursions resemble massive volcanism. Atmospheric shifts resemble biological transitions. Elemental anomalies resemble rare geochemical events. In every case, the natural explanation is sufficient, and sufficiency erases curiosity. Yet sufficiency is not the same as certainty. It reflects probability, not exclusion. Science operates by narrowing possibilities, not exhausting them. The absence of unambiguous evidence does not close the question. It simply defines the limits within which it can be asked responsibly. Within those limits, the idea of recurring intelligence becomes less radical and more sobering. It suggests that the emergence of thought capable of self-reflection may not be Earth's final state, but one of many experiments the planet runs when conditions align. Most experiments fail. A few persist briefly. None are guaranteed continuation. This framing shifts the emotional center of the question. It no longer asks whether humanity is special, but whether it is stable. Whether intelligence can learn to operate without destabilizing the systems that allow it to exist. Whether awareness can extend beyond immediate advantage and adapt to timescales far longer than culture is accustomed to considering. Deep time offers no reassurance. It shows that Earth has no obligation to protect complexity. It also shows that complexity, when it arises, can reshape the planet profoundly, sometimes to its own detriment. Intelligence accelerates feedback loops. It compresses change into shorter intervals. It increases risk as much as capability. If intelligence has appeared before, its disappearance would not be a mystery or a failure of destiny. It would be the expected outcome of operating at the edge of planetary tolerance. The fact that no clear record remains would be a consequence, not a coincidence. And if intelligence has not appeared before, the lesson is unchanged. Earth does not reward novelty with permanence. It rewards alignment with stability. The deeper this is considered, the less important it becomes to resolve the question of first civilization. What matters is that the planet behaves in ways that make lasting intelligence difficult. The challenge is not to uncover lost predecessors, but to avoid becoming one. In that sense, the speculation serves its purpose. It widens perspective without abandoning restraint. It invites awe without demanding belief. It places humanity not at the center of a cosmic drama, but within a fragile interval of opportunity. Earth does not remember intentions. It remembers outcomes. And over deep time, even outcomes fade. What remains is a planet that allows thought briefly, then moves on. As the distance from the present increases, the language of certainty becomes less useful. What remains are gradients rather than boundaries, tendencies rather than events. Earth's past does not present itself as a sequence of clean chapters, but as overlapping transitions where causes blur into effects. Within that blur, intelligence would not stand out as a separate category of phenomenon. It would be folded into the same physical processes that govern climate, chemistry, and life itself. One of the most revealing aspects of deep time is how often birth appears to reset complexity without fully sterilizing itself. After each major disruption, life returns, not as a continuation, but as a reorganization. New forms emerge from survivors. Ecological rules are reassigned. Energy flows are rerouted. The system does not remember what came before, yet it remains capable of generating complexity again. This pattern alone makes recurrence plausible without invoking repetition in detail. If intelligence is a product of such reorganizations, then its appearance would be opportunistic rather than ordained. It would arise when ecological networks become sufficiently dense, when energy gradients become exploitable, and when stability persists long enough for cognition to compound across generations. None of these conditions are permanent. They are temporary alignments in a dynamic system. This makes the idea of a single linear ascent toward intelligence increasingly unlikely. Earth does not move in straight lines. It oscillates. It overshoots. It corrects. Complexity follows those movements rather than directing them. Intelligence, no matter how self-aware, remains bound to that oscillation. What deep time also reveals is how deceptive scale can be. From within a civilization, centuries feel expansive. From geology, they are invisible. From within an ecosystem, dominance feels absolute. From evolution, it is temporary. The same distortion applies to memory. Human records extend back a few thousand years. Beyond that, history thins rapidly. Beyond a few million, it vanishes almost entirely. This distortion encourages a false intuition that what is remembered must be what mattered. Deep time suggests the opposite. Most things that mattered left no recognizable trace. Survival, not significance, determines what is preserved. Against this backdrop, the idea that intelligence could have appeared before and left no clear record becomes less provocative and more consistent. It does not require extraordinary assumptions. It requires only acceptance that Earth is far better at forgetting than recording. The absence of evidence, then, is not a void begging to be filled. It is a property of the system itself. The planet is not designed to archive its own experiments. It is designed to continue. This perspective subtly alters the emotional tone of speculation. Awe replaces curiosity about hidden truths. Humility replaces the urge to uncover secrets. The question becomes less about discovery and more about orientation. How does intelligence behave when it understands how easily it can be erased? Seen this way, speculation about earlier civilizations is not escapism. It is a mirror held up to the present. It asks what kind of trace current intelligence is creating, and whether that trace aligns with stability or disruption. Deep time offers one clear lesson. Whatever cannot integrate with planetary cycles is temporary. Whatever accelerates imbalance eventually encounters correction. Whatever assumes permanence without justification becomes fragile. Whether or not intelligence has arisen before, these constraints remain. Earth does not adapt to civilization. Civilization must adapt to Earth. The most unsettling possibility is not that humanity is repeating a forgotten past, but that the past offers no memory precisely because repetition is the norm. Complexity rises, destabilizes, dissolves, and rises again, each time without inheriting the lessons of the last. If that pattern holds, then the future is not shaped by discovery of ancient traces, but by recognition of present limits. Longevity becomes the rarest achievement imaginable. Not because intelligence is weak, but because the systems it inhabits are vast, indifferent, and slow to change. In the end, the question of first civilization fades into the background. It becomes less important than the conditions that allow any civilization to persist at all. Earth has hosted oceans, forests, ice sheets, and deserts. It may have hosted intelligence more than once. It will host change again. What remains uncertain is whether intelligence can ever become something the planet does not eventually forget. At this depth of reflection, the question has almost fully detached from curiosity about the past and attached itself to the structure of reality that allows intelligence to appear at all. Earth is not static enough to preserve meaning, yet not chaotic enough to prevent complexity from forming. It exists in a narrow corridor between extremes, where energy flows are rich but not immediately destructive, where chemistry is diverse but not frozen into rigidity, where change is constant but not instantaneous. Intelligence seems to require precisely this corridor, and nothing about that corridor is guaranteed to last. What deep time reveals most clearly is that continuity is the exception, not the rule. The planet does not progress toward refinement. It cycles through states that sometimes allow intricate organization and sometimes collapse it back into simplicity. Each cycle does not build neatly upon the last. Information is lost. Structures dissolve. Patterns repeat without memory. If intelligence arises within such a system, it inherits no protection from previous iterations. It begins again, unaware of what may have preceded it. This is why speculation about earlier civilizations feels both plausible and unreachable. The mechanisms that would erase them are the same mechanisms that make their emergence possible in the first place. Tectonics stabilize climate through carbon cycling, yet tectonics also destroys surface history. Oceans moderate temperature, yet oceans erase coastlines and bury evidence. Life builds complexity, yet life accelerates decay. Earth's strengths as a life-bearing world are inseparable from its tendency to forget. Within this framework, the notion of intelligence leaving behind deliberate messages or enduring monuments becomes almost contradictory. Any civilization capable of understanding deep time would also understand the futility of permanence. What might remain would not be intention, but side effects. Altered ratios, slight shifts in distributions, residual imbalances that persist only because they are too diffuse to correct quickly. This reframes the absence of unmistakable evidence not as a puzzle demanding resolution, but as a natural outcome of how planets work. It suggests that if intelligence existed before, it would not be hiding in ruins or artifacts waiting to be uncovered. It would be dissolved into averages and baselines, indistinguishable from the background processes that govern the planet. At this point, the idea stops being unsettling and becomes strangely calming. It removes the pressure to uncover lost greatness or hidden ancestry. It replaces it with a sense of continuity that does not rely on memory. Intelligence becomes something Earth does from time to time, rather than something it accumulates. This also reshapes the idea of progress. Progress implies direction. Deep time offers none. It offers only persistence through adaptation. What survives is not what is most advanced, but what fits within constraints long enough to reproduce itself across change. Civilization, if it hopes to persist, must operate by the same rule. Whether intelligence has emerged before becomes almost secondary to whether it can ever become self-sustaining across planetary change. Can awareness learn to dampen its own excesses? Can technological systems learn to operate below thresholds that trigger collapse? Can societies value longevity over acceleration? These questions matter regardless of what came before. If earlier civilizations existed, their disappearance would not represent failure in a moral sense. It would represent the difficulty of aligning rapid intelligence with slow planetary systems. The challenge is structural, not ethical. The planet operates on timescales that culture rarely considers. As the script approaches its end, the sense of awe no longer comes from imagining ancient predecessors, but from recognizing how narrow the margin for any enduring intelligence truly is. Earth has hosted life for billions of years. Conscious reflection has occupied only a fleeting fraction of that span. Whether it has appeared once or multiple times, its presence is brief against the background of stone. In that light, the most profound mystery is not buried beneath the past, but suspended over the future. Whether intelligence can ever learn to exist without erasing the conditions that allow it to arise. Earth offers no guarantees. It offers opportunity, briefly. When the full arc of Earth's history is held in mind, intelligence appears not as a culmination, but as a delicate negotiation between order and instability. The planet supplies energy gradients rich enough to support complexity, yet it never stops shifting the ground beneath that complexity. Every apparent equilibrium is provisional. Oceans circulate heat until they do not. Ice reflects sunlight until it retreats. Carbon cycles regulate climate until they overshoot. Intelligence emerges inside these moving boundaries, not outside them. This makes the notion of permanence almost incompatible with how Earth functions. Stability exists, but only temporarily, only locally, and only within narrow margins. Life adapts by flexibility rather than control. Intelligence, however, introduces intention, foresight, and acceleration. It concentrates energy and matter in ways that amplify feedback loops. That amplification brings power, but it also brings fragility. Deep time suggests that most systems capable of rapid change struggle to endure slow change. Civilizations optimize for present conditions. They build infrastructure, culture, and knowledge around assumptions that feel fixed. When those assumptions erode, adaptation lags behind reality. Collapse does not arrive as a single moment, but as a gradual misalignment between expectation and environment. In this sense, the disappearance of a civilization would not look dramatic from afar. It would look like deceleration. Less energy moved, fewer materials refined, atmospheric signals relaxing back toward equilibrium, the planet absorbing disturbance as it always does. Over enough time, even memory of disturbance dissolves into noise. This understanding reframes the speculation entirely. The idea that intelligence could have appeared before does not depend on missing evidence. It depends on recognizing how little evidence Earth ever preserves. The planet does not archive attempts. It cycles through them. Whether intelligence has arisen once or many times, the conditions that allow it are rare, and the conditions that erase it are common. This asymmetry shapes everything. It explains why deep time feels empty, despite being full. It explains why the present feels extraordinary despite being temporary. Awe emerges not from imagining hidden civilizations, but from recognizing the improbability of awareness itself surviving long enough to reflect on its own impermanence. Consciousness exists just long enough to notice the vastness it inhabits, then fades back into the processes that produced it. This does not render meaning fragile. It renders it precious. Significance does not come from being first or unique. It comes from existing at all within a universe that does not favor memory. As the question settles, it becomes quieter and more inward. Whether or not this planet has hosted intelligence before, it behaves as though it will erase whatever comes next. The future is not guaranteed by understanding the past. It is negotiated moment by moment through restraint, adaptation, and humility. Earth does not ask intelligence to dominate it. It asks only that intelligence recognize the scale it operates within, to move carefully through cycles that vastly outlast culture, to treat longevity as an achievement rather than an assumption. If intelligence has appeared before, it left no monument. If it has not, that absence carries the same lesson. Nothing that ignores planetary limits endures. The question of first civilization dissolves into something broader and more human. Not who came before, but what it means to be here now, aware for a brief interval on a restless world that has no obligation to remember. Earth continues regardless. Time continues regardless. The only open question is whether intelligence can learn to continue with them, rather than against them. At the end of this exploration, the question that began the journey no longer demands an answer in the way it once seemed to. Whether intelligence has arisen on this planet before becomes less important than what the question reveals about time, memory, and scale. Earth is not a witness in the human sense. It does not preserve intent or recognize achievement. It responds only to energy, chemistry, and motion. Anything that aligns with those forces may persist briefly. Anything that resists them is eventually absorbed. The deep past does not speak in stories, because stories require continuity, and continuity is rare. Instead, it speaks in gradients, cycles, and slow corrections. The planet allows complexity to arise, not as a reward, but as a consequence of temporary balance. When that balance shifts, complexity dissolves without ceremony. Intelligence, however remarkable it feels from within, is subject to the same rule. This realization does not diminish the present moment. It magnifies it. Awareness exists here and now against a background that is overwhelmingly indifferent. Thought has emerged on a world that does not need it, does not preserve it, and does not depend on it. That emergence alone is extraordinary, regardless of whether it has happened before. If intelligence has appeared in earlier ages, it would have lived briefly in geological terms, shaped its environment, and then faded as conditions changed. Its disappearance would not mark failure or punishment. It would mark the end of a phase, just as countless other phases have ended throughout Earth's history. Forests have come and gone. Oceans have advanced and retreated. Ice has covered continents and melted away. None of these states were permanent. None were final. And if intelligence has not appeared before, the lesson remains unchanged. Earth does not grant permanence simply because something is new. It does not preserve awareness out of novelty or importance. It preserves only what fits within its long cycles, and even then, only temporarily. Seen through this lens, the question of first civilization becomes a quiet invitation rather than a revelation. An invitation to think beyond progress and dominance. An invitation to consider longevity as the rarest form of success. Not survival through control, but survival through alignment. Deep time suggests that intelligence is most vulnerable when it believes itself exceptional rather than contingent. The more it accelerates, the more it destabilizes the conditions that allow it to exist. The more it assumes permanence, the more fragile it becomes. The past, whether it contains forgotten intelligences or not, offers no guarantees and no warnings written clearly enough to read. It offers only a pattern. Complexity arises when conditions allow it. Complexity fades when those conditions change. Memory does not carry forward. Each emergence begins again, unaware of what may have come before. What remains then is a single fragile interval in which awareness can choose how it behaves within forces far larger than itself. Not to conquer them, not to escape them, but to move within them carefully, knowing how easily they erase. Earth does not promise remembrance. It does not promise continuity. It offers time, briefly, and conditions, temporarily. Whether intelligence has visited this world before or not, the responsibility is the same. To exist gently enough that existence can continue. And to recognize that awareness, however fleeting, is already enough.